All right, we're now ready to take the derivative of our inverse trig functions, sine inverse, cosine inverse, tangent inverse. And we're going to use implicit differentiation to do that. All right, let's start with y equals sine inverse of x. Now, I don't know how to take the derivative of sine inverse of x, so as any good mathematician should do, I am going to resort to something I do know how to do and see if I can apply it to this. So if y is equal to sine inverse of x, this means that sine of y equals x. And that is true when sine is restricted to a domain where it is where it's 1 to 1. And this, the standard restriction for sine, when talking about its inverse, is negative pi over 2 to pi over 2. Okay, clearly that's a 1-to-1 function, so it has an inverse. So sine of y equals x when y is between pi over 2 and negative pi over 2. Okay? All right, so let's see if we can work with this guy, because we know stuff about this guy, and then see if we can answer that. So remember, I wanted to find the derivative of sine inverse of x. Or better stated, I want to find dy dx when y is equal to sine inverse of x. Okay, so let's take the derivative of this equation with respect to x on both sides. So the derivative of sine of y with respect to x is the cosine of y times the derivative of y, dy dx, which equals the derivative of x with respect to x is just 1. Now remember, what I was in search of was dy dx. So dy dx equals 1 over the cosine of y. Now, this is a true statement, but if I can, I would like to be able to write my final answer in terms of x. So I'm going to come over here, and I am going to draw a triangle that represents this right here. So if the sine of y equals x, then I can draw a right triangle where y is my angle. And since sine of y is opposite over a hypotenuse, x over 1. And now I can just use the Pythagorean Theorem to find this missing piece, which is 1 minus x squared. Okay, so if sine of y equals x, then this is the triangle I get. All right, so I can now talk about the cosine of y, dy dx, in terms of this triangle, which is, so cosine of y is adjacent over hypotenuse, so this over 1. And so 1 over that is 1 over the square root of 1 minus x squared. So I was able to find dy dx implicitly over here because I didn't know how to answer it right there. So if y is sine inverse of x, dy dx is 1 over the square root of 1 minus x squared. All right, let's see if we can do the same thing with cosine inverse. Okay? So here, y equals cosine inverse of x means that the cosine of y equals x on its restricted domain. And for cosine, we can't restrict it from negative pi over 2 to pi over 2 because it's not 1 to 1 there. So our standard restriction is 0 to pi. So as long as y is between 0 to pi, cosine of y has an inverse function. All right, so I want to be able to find dy dx, so I work with this one because I know something about this one, and I take the derivative with respect to x implicitly. So the derivative of cosine of y with respect to x is the negative of sine of y times dy dx equals the derivative of x with respect to x is 1. Solving for dy dx, I get negative 1 over the sine of y. Now, just like before, I'm going to create a triangle based on cosine of y equals x. Make my right triangle. My angle is y. So cosine of y equals x means that that's the triangle that is formed. And this piece right here is 1 minus x squared. So I can write sine of y, which is opposite over hypotenuse, in terms of x. So if y is equal to cosine inverse of x, then dy dx is equal to the negative of 1 over the square root of 1 minus x squared. All right, the last one we want to look at is tangent inverse. All right, so if y equals the tangent inverse of x, what is dy dx? Well, let's write tangent of x in terms of y. Tangent in terms of x. So if y equals tangent inverse of x, then tangent of y equals x on its restricted domain, and the standard restriction for tangent when talking about its inverse is negative pi over 2 to pi over 2, but this time we can't include the endpoints. So y less than pi over 2, bigger than negative pi over 2. Okay, again, let's work with this guy. So tangent of y equals x, take the derivative of both sides with respect to x. You get secant squared y times dy dx equals 1. Solve for dy dx, and you get 1 over secant squared y. And just like before, we will draw a triangle based on this equation right here. So tangent of y, here's my y, is equal to opposite over adjacent, so x over 1, which means the hypotenuse is the square root of 1 plus x squared. So this becomes 1 over the square root of 1 plus x squared squared, or 1 over 1 plus x squared. So if y equals tangent inverse of x, then dy dx is equal to 1 over 1 plus x squared. So let's summarize them on one page for all future use. Oops. Then dy dx is 1 over 1 plus x squared. If y equals sine inverse of x, then dy dx equals 1 over the square root of 1 minus x squared. If y equals cosine inverse of x, then dy dx is equal to the negative of the 1 over the square root of 1 minus x squared. And these three you now need to know forever and ever and ever. So here's a question to ponder as I leave you. What is dy dx of tangent inverse of e to the x?